At the end of lesson 3, you'll be able to use the length formula to find the length of a line segment. I have the XY plane, and on the x-axis I have 2 points S1 and S2, and for the y-axis there are two values Y1 and Y2. Now let us plot these 2 points in the graph. Join these 2 points with a straight line. Now complete the diagram to form a right-angled triangle. What are the coordinates of the endpoints of the straight line indicated in black? The coordinate of the point here B is going to be S2, Y2. The coordinate of the point here A is going to be S1, Y1. Let the coordinate of the third vertex of the right angle triangle be C. Now, what's the distance between the point A and the point C? The distance AC is the same as the distance between these two values. That's S1 minus Y1. S2 minus S1. This is the distance between the 2 points A and C. What's the distance BC? The distance BC is the same as the distance between the two values Y2 and Y1. So we subtract the smaller value Y1 from the bigger value Y2. Now we want to use the Pythagoras theorem to establish the formula for the length AB. We learned from previous lesson that the square of the hypotenuse. Now we see in the diagram that the line AB is opposite the 90 degrees triangle. It's opposite the 90 degrees. And so the square of the hypotenuse AB is equal to the sum of the squares of the other two sides. Now when we take the square root of both sides, our formula becomes this way. This equation star is the length of the line segment AB, whose endpoints are A and then B. The point A and B are vertices of an isosceles triangle ABC. Find the length of the line AB. Length of line AB is written as this, and we have learned that the length of a line segment is given by this formula: square root of S2 minus S1 squared plus Y2 minus Y1 squared. Let the first point be S1, Y1. Let the second point be S2, Y2. Now substitute. Our S2 is 1 minus value S1 is minus 3. Our Y2 is giving us 4. Our Y1 is 2. Now it's minus 3. That gives us 1 plus 3, 4. 4 squared is 16. 4 minus 2 is minus 2. Minus 2 squared gives you 4. So we are getting root 20, which in turn gives 4.47 units. So this is the distance between the 2 points A, B in the XY plane. And next question. The distance between 2 points P and Q is 5 units. Distance between P and Q is written as this, and we use the formula S2 minus S1 all squared, Y2 minus Y1 squared. Now let the point P be S1, Y1. Let the point Q be S2, Y2. Now question says that the distance between the 2 points PQ is 5. So in place of what we have at the left hand side, length PQ 5. Let's substitute. Our S2 is 7, S1 is 10, Y2 is A minus Y1 3. So we get 5 equals square root of, now 7 minus 3 gives you minus, 7 minus 10 gives you minus 3 squared is 9, A minus 3A is minus 2A, minus 2A squared gives you plus 4A squared. Now take the square of both sides. When you take the square of both sides, you are going to get 25 equals 9 plus 4A squared. So we now write 16 equals 4A squared. When you divide both sides by 4, we are going to get A squared equals 4. Now take the square root of both sides. We are going to get the value of A to be plus or minus 2. Plus or minus 2 because when you do plus 2 squared, you are going to get 4. When you also do minus 2 squared, it will also give you 4. And so the values of A are minus 2 and then positive 2. We've learned that when you want to find the distance between 2 points, now in this diagram the two endpoints are G and H, so we'll write length of GH equals square root of difference in the S value squared plus difference in the Y values squared. See you in the next lesson.